Hello, my name is Naila Ubaid and the topic of this presentation is plastic waste pollution and recycling. This project is concerned about the effect of plastic waste on our environment, waterways, ocean and wilderness habitat, which ultimately affect our food chain, health and the livelihood of people. The issues surrounding plastic waste pollution and recycling and possible cost-effective solution to help manage the problem were investigated and will be presented along with key findings. In the traditional linear economic, people dispose plastic 1.7 times more than what the earth can sustain. Plastic is a non-biodegradable material which create pollution and threaten wildlife, marine life and their habitat. Once in the environment, plastic degrade into particles of microplastic through natural weathering process over time and then get transported to our waterways through wind, rain and tides. The risks posed by microplastic on the aquatic environment is a critical concern. Over 1 million tons of plastic waste reach our ocean globally every year and harmfully affect ecosystem, biodiversity and possibly human health. The likelihood of disease increases from 4% to 89% when coral are in contact with plastic. In 2017, Australia generated 67 million tons of waste with an estimated 130,000 tons of plastic waste ending up in our ocean and waterways. In 2018, China refused to accept Australian waste, forcing Australia to deal with its growing waste problem and pollution. I found that the current global industrial technique to recycle plastic is mechanical recycling. Plastic material degrade and downcycle during the process and the resulting material could be used to make pipe, electric wire cover, plastic bags and other household products. However, most of this recycled material finally become unrecyclable waste material and dumped into the landfill. The limitation of mechanical recycling led to a growing interest to chemical recycling. This type of recycling has high potential for processing contaminated plastic waste material with chemical recycling. The quality of plastic does not degrade and the resulting material is of similar quality as the original material, which can be used to produce plastic chemicals or energies. With chemical recycling, it may be possible to divert most of the plastic waste from landfill to recycle when all the plastic waste are equal and circular and reusable and infinite numbers of times. Scientists have found ways to turn plastic waste into nanomaterials, which can be used to make rechargeable batteries, as it is expected that 30% of the world car fleet will be electric by 2040, and the high cost of sourcing raw material for batteries is a challenge. Therefore, their research helps solve the problem of cost-effective and sustainable battery production and help reduce plastic pollution. It is important to support all steps of circular economy. People can change their practices to sustainable practices with the use of 4R economics such as refuse, reduce, reuse, recycle and prevent the plastic waste from entering the environment and going to landfill. Plastic waste management and pollution is a global issue with constantly growing challenges worldwide. The drawback of the chemical recycling process, which is currently popular in industries, is that each recycle degrades the material quality, finally resulting in unrecyclable waste material. An alternative to mechanical recycling process is chemical recycling, which has a high potential for recycling mixed and contaminated plastic waste material. However, the method is not popular and less cost effective. Therefore, stakeholders should care for the environment through sustainable practice of reducing plastic waste and pollution. Thank you.